Hey guys, so in this video I'm going to be solving grid questions 1 to 9 which are included in chapter 1 of the math final. So let's start with the steps for solving limits. The first thing you want to do when they give you a limit is you want to substitute the number that x is approaching. And if you get 0 over 0, if Mr. Khatib was here, it'd be like 0 over 0, it means as if someone is telling me be careful. There is limit, go find it. Okay, so if you get 0 over 0, then you can't use that because that's undefined. So you need to rationalize, simplify, factorize, depends on what they give you. And then if they gave you limit as x approaches 0 of sine x over x is going to be equal to 1. And the same thing for tan x over x. Now if you substitute and you get an answer like 3, 7, something that does not have 0 in the denominator, then you can use that as your final answer. In grid question number 1, they gave you this limit and they told you to solve. So the first thing you would do is you would substitute x equals to 16 into this equation. And if you do that, you would get 0 over 0. So we can't use that. So the next thing you would do is you would try to change this in a way to remove 0 from the denominator. So the first thing you would do is that you would factorize x squared minus 256. You could write it as x minus 16 times x plus 16. Now you try to cancel something in the denominator, but here we can't cancel anything. So the next thing you would do is you would rationalize radical x minus 4. So you'd multiply radical x plus 4 up and down. And then in the denominator, it's going to turn into x minus 16, which would cancel with the x minus 16 in the numerator. Now, because we got rid of that denominator, we can try to substitute. So if you substitute here, you will get 256. So 0 would not be in the denominator anymore. So this would be your final answer. So before I go to question number 2, there are some formulas that we need to know. The first formula is that sine ax is equals to a sine x times cosine x. A is going to be taken outside and then you multiply by sine x times cosine x. The next three formulas are the trigonometric equations. Most of us already know the first one, sine squared x plus cosine squared x equals to 1. The other two are kind of harder to memorize. So if you do not want to memorize it, if you don't want to memorize these two, you can just memorize the first one and then you can get the second one by dividing this whole equation by sine squared x. And in order to get this equation, you can just divide this whole equation by cosine squared x. That way you can just memorize the first one and you can derive the other two easily. So for grid question number 2, they gave you this limit and then they gave you options and you need to pick which one is correct. So the first thing you would do is you would try to solve this limit. If you substitute x equal to 0 into this, you're going to get 0 over 0, and we can't have that. So we take 2 as, so we need to find another way. So the first thing we do is take 2 out as a common factor, because we can easily tell that we can take 2 outside. After that, we still have the main problem that sine 2x in the denominator would turn into 0, and we can't have 0 in the denominator. So we take 2 outside because we can write this as 2 times sine x times cosine x. But we still have sine x in the denominator now, which is also still a problem. So if you remember the equations that we took before this, sine squared x plus cosine squared x equals to 1. If you take cosine squared x to the other side, it will become sine squared x equal to 1 minus cosine squared x. So if we can turn this into 1 minus cosine squared x, we can substitute it for sine squared x, which would cancel the sine x in the denominator and then eliminate our problem. So now we will multiply up and down by 1 plus cosine x, and then we will have 1 minus cosine squared x in the numerator. Then we can substitute 1 minus cosine squared x with sine squared x. So now we have sine squared x in the numerator. Then we can cancel sine squared x up and down. So now we have sine x in the numerator, but we don't have any sine x in the denominator. So now if you substitute x equal to 0, there is nothing that's going to turn the denominator into 0. So it will be 0 over 1 times 1 plus 1, which is 0. Now we finish the hard part. Now you look at the options and you see which one has the final answer equal to 0. Whatever has final answer equal to 0 is correct. Also, if you see any of the options that look exactly like one of your steps, then that's also correct. Grid question number 3 is almost the same as grid question number 2. So they gave you the limit and they gave you options and you need to pick the correct ones. So the first thing you want to do is substitute x equals to minus 5 into this equation. You would get 0 over 0. So you need to find another way. So now you want to rationalize the denominator. So you multiply radical x plus 6 plus 1 up and down, so that now in the denominator to be x plus 6 minus 1, so to be x plus 5. Now you can cancel x plus 5 up and down, and that way you will have this. So now if you substitute x equal to minus 5, you're not going to have 0 in the denominator, and you end up with 2. So now you go to your options and you pick which ones match your calculations and your final answer. Also, I forgot to mention that whenever you have questions like this with a radical in the denominator, most of the time you would rationalize in order to get rid of that radical, and then the calculations would be easier, and then you can simplify and cancel up and down. That's why most of the time when there is radical, I'm always rationalizing. So for question number 4, they gave you this limit and they want you to solve it. If you look at this, it can kind of remind you of this rule that we learned before. But in order for us to use this rule here, we need to split this equation into 2. So we would split it here, and it will become limit as x approaches to 0, and as x approaches 0 of 5 sine x over 5x, plus limit as x approaches 0 of sine 10x over 5x. Now, this 5 will cancel with this 5, and limit as x approaches 0 of sine x over x is going to be equals to 1. So this whole thing now is 1. Here, limit as x approaches 0 of sine 10x over 5x, in order for us to use this rule, this has to be equal to this. They have to be the same thing. So in order for us to make the denominator 10x, we have to multiply up and down by 2. So you multiply up and down by 2, you'll have 1 plus limit as x approaches 0 of 2 sine 10x over 10x. Limit as x approaches 0 of sine 10x over 10x can turn into 1, and then you'll be left with 2. So 1 plus 2 is equals to 3, and that's going to be your final answer. For question number 5, they gave you this limit, and they said the final answer is going to be k over 4, and they want k. So the first thing you want to do is you want to make this equals to this, because if you make these two the same number, then you can use this formula, which is limit as x approaches 0 of tan x over x is going to be equals to 1. So if you can make 8 become 18, then you can use this and make this whole thing equal to 1. So how do you make 8 18? So you do 8 times a number should be equals to 18, and that number should be 18 over 8. So that means if you multiply 8 by 18 over 8, you're going to get 18. So you multiply 18 over 8 up and down in this fraction, and then you will have 18 over 8 times tan 18x, and down 8 would cancel with 8, so it would become 18x. Now because you have limit as x approaches 0 of tan 18x over 18x, you can take this and make it 1. So you'll be left over with 18 over 8, and that's going to be your answer. But they said they want it they want it as k over 4, and they want k, so they want the denominator to be 4. So what would you do? You need to divide up and down by 2. That way you can have 9 over 4, and so k will be 9. That's your final answer. So now let's talk about epsilon and delta. So what epsilon and delta mean is just a small positive number, and these are the two formulas that you need to know. And what do they actually mean? Well, let's take this function for example. If we have a point x here and its corresponding point fx, as we approach x, we're also going to be approaching fx. So when we're approaching x, we're getting very close to x, but we're never at x. So let's name that point b. And when we're approaching x, we're going to be approaching fx. but we're never going to be at fx. So let's name that point which is very close to fx, which we're approaching fx. Let's name that point L. So L means we're just approaching fx, and D means we're approaching x. What these two equations mean is that fx minus L is epsilon, which is a small positive number. And it makes sense because fx and L are very close to each other. So it's going to be a small positive number. And this x minus D is delta, which just means a small positive number. And it makes sense because x and B are very close to each other. But why an absolute value? Because let's say L was above fx, then fx minus L would be negative, and epsilon means a small positive number. So we can't have this being negative. So that's why I put an absolute value, and the same thing there. And that's it for epsilon and delta. In question number 6, they gave you this function and they gave you these two equations. And they said at epsilon equals to 0.1, what's the largest value for delta? And they said delta is going to be 1 over k, and they want k. So the first thing you would do is you would use this equation. You already know what's fx and you know what's epsilon. So you just substitute fx and epsilon, you get 5x minus 6 plus 6 here. So 6 and 6 will cancel. So then you have 5x in absolute value less than 0.1. Now you need to make this part look like this part. Because then if this part looks like this part, then these two have to be equal. So what we do now is divide by 5 here and by 5 here. So now we have x in the absolute value less than 0.1 over 5. So this is the same as this. It has the same sign, so these two have to be equal. So what we do now is we equate them. So delta is equal to 0.1 over 5. Here they said delta is 1 over k, so they want the numerator to be 1. So we multiply up and down by 10, and that way we have 1 over 50. So k will be equals to 50. So one more thing is, why did they write it like this? Didn't I say it would be less than or equal to, and then you have another less than or equal to, and then 0? Sometimes they don't write these extras, they just get straight to the point. And that's it. Okay, that's it for this video. I know I said I'm going to do until question 9, but I don't have charge in my tablet right now. And if you're wondering why I'm talking like this, is because if I talk normally, it's just going to be boring talking about numbers all the time. So that's why I'm talking like this. And I'm going to continue in the next video. Bye!